Okay, now see this question number 34 from chapter 24 of HC Verma. A glass tube sealed at both ends is 100 centimeter long. This is a 100 centimeter long glass tube. It lies horizontally with the middle 10 centimeter section containing mercury. So here you can see is a mercury column 10 centimeter long. The two ends of the tube contain air at 27 degrees Celsius and at a pressure of 76 centimeter of mercury. So here we have air at 300 Kelvin and 180 m. Here also air at 300 Kelvin and 180 m. Okay. So what is the length of the air column? Here we will have 45 centimeter and here also we will have 45 centimeter. Now what happens? Now the air column on one side is maintained at 0 degrees Celsius and the other side is maintained at 127 degrees Celsius. Calculate the length of the air column on the cooler side. Okay. So now what will happen? In this new situation, let's say this mercury will shift on one side. Why would it shift on one side? Because the air on this side will now be at 0 degrees Celsius or 273 Kelvin, and the air on the other side is being maintained at 127 degrees Celsius or that will be 300 Kelvin. So this side will expand and this side will contract. The length of the mercury will not change, it will still be 10 centimeter. Okay, so let the new length be L1 and this side is L2. Okay, so according to question, we have to find the length of the column on the cooler side. So we have to find the value of L1. Now there's one interesting thing that you need to note. See, the air column on this side will apply a force F. Equal force should be applied by the air column on the other side. So since both the forces are equal from both the sides, pressure will also be same on both the sides. Pressure will be P on either side. Now let's just look at this left side section. Since number of moles of air is not changing, so we can say that P1 V1 upon T1 equal to P2 V2 upon T1 T2. So P1 into V, instead of V1 we will write the length 45 centimeter upon T1. So I can write down 180 m into volume V1 is 45 centimeter. Instead of V1 I am writing the length divided by temperature is 300 Kelvin. This will be equal to P into P into L1 by 273. P times L1 by 273. Okay. So we will obtain that PL1 will be equal to 273 into 45 by 300 ATM centimeter. Okay. Now let's look at the other side. So on this side, initial pressure 1 atm, initial temperature 300, and final temperature will be actually 400 over here. Okay, 127 degrees Celsius means 400 Kelvin. My mistake. So now I can write down P1 L1 upon T1. So 1 into 45 centimeter by 300 is equals to P times L2 divided by 400. So I get P times L2 will be equal to 400 into 45 by 300 atm centimeter. So now we will get P is equal to 273 into 45 by 300 L1, that is equal to 400 into 45 by 300 L2. Then I will get L2 is equal to, in the equation let's cancel out 300 and 45. So we will get L2 to be equal to L1 times 400 by 273. Okay, now look at this. The total length of the tube is 100 centimeter. This is 10 centimeter. So L1 plus L2 will be 90 centimeter. So I can write down L1 plus L2 is equal to 90 centimeter, or L1 plus 400 by 273 L1 equal to 90 centimeter. So you will get L1 to be equal to 90 into 273 divided by 400 plus 273 centimeter. When you simplify this, you will get 36.5 centimeter. So this is the answer.